Hi friends, this is PH 1501, Unit 1, Vector Analysis. In this lecture, we will be focusing on point number 2.7, that is second derivatives. We will be learning in this unit a few operators applying on the gradient, on the divergent and on the curl, and therefore when a del operator is applying in a different fashion on a gradient, divergence and curl respectively, you have or we have varieties of the options are possible. Let us have a glimpse of that in very brief, because on this basis you will be having some numericals and you have to calculate. So rather you have to make a few practice for the few small varieties of the examples. As it is mentioned here, the second derivatives, so the idea is very clear. Those who are with the finished their 12th grade with the A group, they are knowing that what it means by second derivatives. B group students may be not aware little bit. Derivatives you are knowing, so applying a differentiation, and second derivative, that means a second order differentiation. So you can look at the equation number 42. So it's a second derivative. You are applying a del by del x 2 time on a respective one derivative already. So that is what the mean of the second derivatives. So the applying the derivative operator on the result which is already developed because of derivatives. So ultimately there is a two derivative functions are applying on either scalar or the vector property. So let's see in the detail. The gradient, the divergence and the curls are the only first derivatives that we have seen in the previous lecture. We can make with a del by applying del twice. We can construct 5 species of a second derivatives. So यहाँ पे ये बोल रहे हैं कि एक डेल तो ऑलरेडी लगा चुके हैं, दूसरा अगर डेल ऑपरेटर उस पर दूसरी बार लगाया, so we will be having 5 varieties of the second derivatives. What are those? 1, 2, 3, 4 and 5. Let us see them in detail. The gradient del t, so you should remember the t must be the scalar, because the gradient will be only applicable on the scalar parameter, scalar quantity, and the outcome will be vector. So gradient will be a vector. So we can take a divergence and curls of it. So divergence and curls of a gradients, that is what our motive in the very first segment. So divergence of a gradients. What is the divergence? Divergence is a dot product with a del operator. What is a curl? What is a curl? Curl is a cross product with a del operator, and that is what we are highlighting here, divergence of a gradient. So if t is a scalar quantity, we are applying just a del operator on that. So this del t is a gradient of a t, that would be a vector, and if it's a vector, I may having a two kind of a option for a second derivative, either it would be a dot product or it would be a cross product. So I am executing both del dot delta t and del cross delta t. If I say del cross delta t, so delta t is a gradient, so I should put it in a word like this, curl of a gradient, and here I should say it's a divergence of a gradient. Okay, let us see what it is. And you can look at here, the gradient is a vector operator which operates on a scalar function and produced a vector. whose magnitude is maximum rate of change of the function at that particular point where you are going to execute a gradient, and which is pointed in a direction of the maximum rate of change. So gradient is ultimately finding out on a scalar function. The scalar function rate of change of the function at that particular point where it get maximized, that is what the mean of the gradient for that point, and which is pointed in the direction of getting maximized rate of change in that particular direction. So this is what given by, suppose f is a function, so del f can be written as del operator, that means I or the x cap del by del x, y cap del by del y, z cap del by del z, or you can say I cap del by del x, j cap del by del y, k cap del by del y, and the f is as it is. So on f you are applying a del operator. Okay, so with this is what our previous thing what we have seen. So that is a del operator over here, and now we are applying this curl functions or the divergence function. So the divergence del v is a scalar because this will be a vector, and this is also a vector, and the dot product, so dot product will be a scalar, and all we can do it is take it's a gradient. Okay, so now gradients of a divergence, so divergence will be always taken of a scalar, you should remember that. That means if I will take it del dot v, so that would be a scalar. So if it's a scalar, then I can take the gradient of it. So gradient of a divergence is possible. Some people are saying that is it possible to take a gradient of a curl? It's not possible because the curl is always a vectorial property and gradient cannot be taken of a vectorial. Okay, the fourth one is a divergence of a curl. So divergence will be taken place with, that is a dot product of a vector with a del operator. So del cross v, that is a cross product of a del and v, and that would be a vector, and that vector and the del operator may have a dot product, so that is a divergence of v. And same way the curl of curl, so that would be the del cross of del cross v. So that way this exhausts the possibilities, and in fact not all them give anything new. Like this is the simplest case what we have taken, the divergence of a gradient, that is a point number 3, divergence of a gradient, point number 1, that is a del dot del t. How shall I write it? Del, that means the very first del operator, so x cap del by del x plus y cap del by del y plus z cap del by del z dot, so this dot is same here, and then it's a gradient of t, so del t by del x x cap plus del t by del y y cap plus del t by del z z cap. Now x cap dot with only x cap may exist, x cap dot y will vanish off base because they are orthogonal to each other, and same way x cap dot z cap will also vanish off, and therefore del square t by del x square, that is your first product of a first step to this entire bracket. Let me repeat again, x cap and y cap की डॉट प्रोडक्ट ज़ीरो हो जाएगी, x cap और z cap की y डॉट प्रोडक्ट ज़ीरो हो जाएगी, x cap dot x cap is equal to 1, so only the first multiplication will do exist, so del by del x of del t by del x, so ultimately del square t by del x square, वो फैक्टर यहाँ पे आ गया, and similarly for the sec y cap factor and then the z cap factor. Okay, so let's go to the next page. Okay, and over here we have seen that the object we write del square t for a short. It is also well known as a Laplacian of a t. What is a Laplacian of a t? That means it is a divergence of a gradient. That is the option number 1 what we have seen in the previous slide. That is a divergence of a gradient del dot del t. So ultimately del और ये del का dot product हो जाएगा del square. So this can be written as del square t, and that is also known as a Laplacian. In the case of a Laplacian, basically we are getting it represents the flux density of a gradient flow of the function. So suppose you want to find it out the flux density of a gradient flow, then you should find it out the Laplacian. Okay, so let's move ahead with the few lines of this. Laplacian of a scalar t is scalar. Laplacian of a scalar t is again the scalar because it's ultimately a divergence of a gradient. Gradient is a vector, but divergence, that is a dot product, and dot product is always a scalar. So ultimately Laplacian is nothing but the scalar. Occasionally we shall speak of a Laplacian of a vector. It's a very rare event that when you are finding out the Laplacian of a vector. Okay, the second option that what is there, that is the curl of a gradient. So I told that in beginning, one is a divergence of a gradient and second one is a curl of a gradient. Gradient, that is, let us say in our case t is a function, so I do have a gradient that is a del t is a gradient. Okay, and then you are taking it become a vector, so del cross gradient is possible, but it is always a 0. Now if I want to see the basic outcome of a Laplacian as well as the curl of a gradient, let us try to visualize what it is. And therefore let me open up this file and note so we can having an idea what it mean by the Laplacian. Laplace operator or a Laplacian is a differential operator given by divergence of a gradient. Divergence of a gradient, that is del dot del t, or it is a function rather the divergence of a gradient of a function on a Euclidean space, or we can also understood I mean in addition to this, the Laplacian represents the flux density. So that is already we have seen that suppose there is a, we need to find it out the density of a gradient flux or the gradient flow, then we can find it out the Laplacian of that particular function. Let us take it del square, so del dot del, and that would be, it is written here del square del x, del square by del y square, del square by del z square, and applied to a function. Let us say f is a function, so del square f by del x square plus del square f by del y square plus del square f by del z square. So ultimately हम क्या कर रहे हैं, we are just finding out the second derivative of a function, second partial derivative of a function. That is what the mean of a Laplacian. और वो कब करते हैं, जब हमें कोई भी डाइवर्जेंस ग्रेडियंट्स तब ढूंढा जाता है when you are interested to find it out the flux density of a gradient flow. Okay, so let's go ahead with the book values and so on. So second one is a curl of a gradient. Now curl of a gradient is always comes to be 0. Now what it mean by curl of a gradient? So let us try to understand by opening up this pinup point, and there said that the curl of a gradient, that means let us say we do have a function f, that is a f of x, y and z, that is a scalar functions. Okay, so there is a gradient is possible. So f function का मैंने स्केलर फंक्शन का मैंने ग्रेडियंट निकाला, सो डेल एफ बाई डेल एक्स, डेल एफ बाई डेल वाई एंड डेल एफ बाई डेल जेड। ये लेने के बाद सो ग्रेडियंट एफ विल बी vectorial function. If it's a vectorial, I can go for the कर्ल ऑफ इट। सो अगर मैं इसका कर्ल लूँ, माने डेल एफ को, माने ग्रेडियंट ऑफ स्मॉल एफ को मैंने कैपिटल एफ से डिनोट कर रहा हूँ, सो कर्ल ऑफ कैपिटल एफ दिस इट्स ऑलवेज ज़ीरो। अगर मैं कर्ल एफ निकालूँ, सो आई कैन राइट इट आउट इन दिस शेप, राइट। और यू आर नोइंग दैट हाउ टू टेक द कर्ल ऑफ इट, सो यू कैन गो विद द मैट्रिक्स। और मैट्रिक्स में अगर मैं ये ले लूँ कि first line of the matrix would be x cap, y cap, z cap. Second will be the del operator, so del by del x, del by del y and del by del z. And the third will be the gradient, so that is a delta f, so that is a del f by del x, del f by del y and del f by del z. That would be the third row. Okay, if with this particular matrix, if I wish to resolve it, the curl of del f will come into this shape. So del square f by del yz minus del square f by del zy. Del yz and del zy will be same, so this will be cancel off, this will be cancel off, and the third point will be also cancel off. So ultimately curl of gradient will always comes to 0, that you can prove it. But this is a mathematical way of understanding what it mean by exactly the understanding of this one. So if you have any scalar function, then अगर scalar function का अगर आप gradient ले रहे हो, तो you are just having an idea that where it is getting maximized, correct. But the scalar function is basically having a uniform value throughout the medium, and if there is a uniform value of throughout the medium, naturally it doesn't have any curvilinear variation, any circular variation in your vectorial field, and therefore the curl of a gradient has to be 0. Okay, so let's go ahead with the concept of it, then go to the next slide, and we will be going with the third variety of the second derivative, that is a gradient of a divergence. Gradient of a divergence, here it is written with a bold letter, gradients of a divergence. So if I will take a divergence of anything, any vectorial variation, then naturally it will be having the divergence will be always the result as a outcome as a scalar, and if it's a scalar quantity, then naturally you can go with the gradient of it. So you can definitely take the gradient of a divergence, and this will gives us the information how fastest the gradient function is varying, that is means the divergence function is varying in the vectorial field or in the vectorial space. So that is what we can having over here. So let us check it up with the gradient, that is the del function is applying on a del dot v. So here it is required to mention it out, this is del of del dot v, it is not same as the Laplacian. Students are mistaking sometime del square v and getting equate with del dot del v, which is not exactly the same as del of del dot v, because if you take it very minutely of this one, then this is del dot del, that means it is itself the scalar, and that second derivative is applying on the v, so that is what the mean of Laplacian. Okay, and over here del dot v is the scalar, and on this scalar you are applying the gradient. Okay, because to have the gradient one should have the scalar quantity. So in nutshell, the gradient of a divergence is quite different than the Laplacian. Okay, Now divergence of a curl, it is also finding out that it is always lying 0. Here also you can prove that del cross y, and then you can take the del dot del cross y, and that always comes out to be 0. You can simply take it a vx, vy, vz and take a derivative, curl derivative with the or the curl product of the vector vx, vy and vz. Then you can having the idea of a del cross v, and then you can take it a divergence of a del cross v, and you can prove it. It is exactly always the 0. So you should remember that I can ask a small questions. I will give you any vectorial function over here, and I will ask you to find it out the divergence of a curl. Then you should actually doing del dot del cross v. So how to understood that? You should operate from right to left. So first you have to find it out the curl, and then you should go with the divergence. अगर gradient ढूंढना है, then you have to first find the gradient ढूंढना है, then you have to go with the v and you have to apply the del operator on it. So same way go with the right hand side to the left hand side. Okay, and in the last segment, that is the 5, that is the curl of curl, and that would be del cross of del cross v. So if I will expand them, it will become a gradient of a divergence minus a Laplacian of the v, and this is the expansion of a del cross of del cross v. And suppose I ask you the find it out the curl of curl v, then it is simply you have to do, if you are able to remember the RHS part of it, you can definitely execute. So this is a very tricky thing. मैं अगर आपको v का वेक्टर का फॉर्मेशन कुछ दे दूँ, और अगर मैं कर्ल ऑफ कर्ल ऑप्शन के लिए 4 ऑप्शन दे दूँ A B C D, so you have to do a rough calculation somewhere in your rough pages, and you have to dig it out the correct answer out of it. So curl of curl gives nothing new. First term is just the equation 3, that is what I said, the gradient of divergence, and the second is the Laplacians. So equation 47, that is exactly resembles from the earlier 4 varieties or 4 species of the secondary what we have seen just upstairs in the slides ups. So let's go to the next one and the last slide, and here we having some examples are given over here. I wish that you can try it out by yourself, the problem number 26, problem number 27 and problem number 28. Otherwise I will going to do the executions of on a one piece of paper, and I will definitely put it on followed by this lecture. All the best for solving this 3 examples. Please do keep practice of such a small examples. So let us say what they are asking me to do, they are Laplacians to find it out. If I want to find it out the Laplacian of it, then naturally I have to do the second derivative. अगर मैं मुँह से ही अगर आप ऐसे ही कैलकुलेट करके बताऊँ, तो फर्स्ट डेरिवेटिव ऑफ x का ये क्या होगा, डेल बाई टी ए बाई डेल एक्स, ये फर्स्ट डेरिवेटिव हुआ, तो इसका हो जाएगा 2x, इसका हो जाएगा 2y प्लस 0, करेक्ट. फिर हो जाएगा डेल बाई डेल वाई, तो ये 0 हो गया, यहाँ पे 2y हो गया, ये 0 है, ये 0 हो गया. डेल बाई डेल z, डेल टी ए बाई डेल z, तो ये दोनों टर्म 0 हो जाएगी, सिर्फ यहाँ पे 3 बचेगा. ये फर्स्ट डेरिवेटिव हो गया. सेकेंड डेरिवेटिव माने डेल स्क्वेयर बाई डेल एक्स स्क्वेयर. तो x का सेकेंड डेरिवेटिव अगर लो, तो पहले x का हो गया था 2x और यहाँ पे हो गया था 2y. सो 2x प्लस 2y का अगर मैं डेरिवेटिव ले रहा हूँ, सो 2y का 0 हो जाएगा और यहाँ 2x का आ जाएगा 2. फिर y का अगर मैं सेकंड डेरिवेटिव लूँ, तो इसका तो 0 आया था, यहाँ पे 2x था, तो 2x का तो डेरिवेटिव हो नहीं पाएगा, तो वो 0 हो जाएगा. और डेल सेकंड डेरिवेटिव ऑफ z का अगर मैं लूँ तो वो भी नहीं हो जाएगा, वो भी 0 हो जाएगा. सो आंसर मस्ट बी 2. सो दिस वे you can calculate the gradient. Again, in examples I may ask you to find it out the Laplacian, and you have to find it out 1 or 2 Laplacian out of 4 correct 4 answers. You have to find it out the correct value of the outcome. सो वेक्टर रियल यूनिट है वो वैसे इजी गोइंग मार्क अचीवर्स है, लेकिन आपको थोड़ा प्रैक्टिस करने की ज़रूरत है. यही एग्जांपल 2-3 बार करते रहिए. ऐसे ही कुछ एक सिंपल एग्जांपल मैं रख दूंगा जिसकी डेरिवेटिव्स आपने कर ली हो, तो 2 टाइम डेरिवेटिव्स करनी है, पार्शियल डेरिवेटिव, एंड यू कैन हैविंग द आंसर्स. करेक्ट. ओके. सो stay home, stay safe, keep reading, keep practicing. All the best.